Number 9. Find the mass of each of the following. Now, in the last problem, in number 8, we were converting everything into the number of molecules. Now, let's convert everything into mass, because these are different quantities that you might be asked to solve for. So let's get a couple of practices in here. So, A, 2.25 moles of chlorine. Now, I need a conversion factor that allows me to convert out of moles of Cl2 and into grams of Cl2. Okay, so that way when I multiply them, those moles go away. But what's the mass of Cl2? Well, it's twice that value right there on your periodic table. It's the molar mass of Cl. Now, it's Cl2, and so you have to take that value and multiply it by 2. So that's 35.45 times 2, 70.9. So for every 1 mole of CO2, there's 70.9 grams of Cl2. Notice that my units will be in grams of Cl2. I'll simply multiply my 70.9 by the 2.25, and I get a number, let's see, sig figs, 3 sig figs, 3, so this needs to be 3. So that 5 right there tells me to round this up, so I'm going to stick with 160 as my final answer, but in order to make sure that you're counting this 0 as significant, I'm going to place that decimal in there right after the 0. So 3 sig figs, 160 grams of Cl2. Alright, we have number of molecules for B, so that means we're going to have to go from the number of molecules into moles using this same statement of equality up here, Avogadro's number, and that'll put us in terms of moles. And then once we're in moles, we can use the molar mass of this substance in the same way we did on part A. So we need to cancel out molecules, and we need to go into moles. That way molecules cancel. Once we're in moles, I can cancel out of moles and go into grams. Well, I don't know what the molar mass of H2S is, so let's calculate it. So I need the molar mass of S right there on your periodic table, 32.06. 32.06 plus the mass of 2 hydrogen atoms, 34.08. Now moles will cancel with moles, and I'm left with grams, a mass. So let's plug everything in. Now again, I'm not going to mess with times 10 to the 23rd because, well, I have a times 10 to the 23rd dividing by a times 10 to the 23rd, so they'll cancel. Right? They will cancel, so I don't have to worry about them at all. So the 34.08, I'm going to multiply it by this given value, 3.01, and then I'm going to divide by this Avogadro's number to end up with this number. Let's see, how many sig figs? I need 3 sig figs again because I started with 3 sig figs. So I'm going to report 3 sig figs. That 3 tells me to leave that 0 alone. So I'm just going to report 17.0 grams. 17.0 grams of H2S. Lastly, 25 molecules. That is a small number of molecules. That's very little. But we're going to use the exact same strategy that we just did. We know that we need to cancel out of number of molecules, and the way we do that is we use Avogadro's number, which is number of molecules per 1 mole. Those molecules will cancel. Once I'm in moles, I can cancel out of moles and go into grams of that substance. That way those moles will cancel, and the only unit I have left in here is grams, right there. But what is the mass of 1 mole of SO2? Well, we already looked at the value for sulfur, 32.06. So 32.06 plus the mass of 2 oxygen atoms, end up with 64.06. 64.06. Now multiply across. Then divide. Okay, so three sig figs, right? Sorry, 3 sig figs right there. My answer is going to be round to that spot. So that 9 tells me to round this up. So I'm going to go 266. 266 times 10. Oh, we divided by an exponent. Oh goodness, what do we do? What do we do? What do we do? Remember, when you divide by an exponent, you subtract it. That's actually to the negative 23. But that right there is not proper scientific notation. Okay, that's not proper scientific notation. I would have to move the decimal in between the 2 and the 6 right here. So 1, 2 to get to 2.66 times 10 to my new exponent. Now, this number right here was 266. 266. That's above 10. That's why it wasn't in proper scientific notation. So I had to move the decimal because this value was too large. So when I change this exponent down here, I have to reflect the fact that this number is too large. How do I do that? By making the exponent larger. Now that's a negative sign. So to be larger, I would actually change that to the negative 21st grams. It's a very, very small mass because we have a very, very small amount of stuff, only 25 molecules.